So up next we have Kevin Lucey, who's the habitat coordinator here with the coastal program, which is part of the New Hampshire Department of Environmental Services. Thank you, Kevin.
Great. So thanks. It's good to be here. I will be talking about permitting at DES, and I should say that I'm not a permitter. It's not in my job description, but I have implemented restoration projects and have prepared, performed due diligence inquiries, prepared permit applications for, for the past 15 years or so, particularly on certain provisions related to restoration. So today I'm providing basically an editorial on the rules, and which is going to be kind of fun. So we have the coastal program has about 10 staff. We've got 3 major focus areas, habitat being one of them. We also have a resilience program, community planning and flood risk planning. And then we also focus on coastal consistency, which is a quasi-permitting program and includes dredging and energy siting. So I'm just going to leave this up, let you read it. It's probably too simplistic to say that rules are made of words, and we're trying to define all the stuff that you heard from Dave and Tom. We have to put words around that, and then we have to create rules related to these concepts. And so primarily here you can see that living shoreline is an erosion control practice. And so this is what DES uses to define living shoreline and how it's permitted. In 2019, we implemented a whole host of new coastal rules, and in that we created certain new preferences. And so the department now has a preference to build living shorelines, and we actually also dissuade the construction of new seawalls. And so you can see words like with a preference for, and tidal stabilization shall be accomplished with living shorelines unless it's not practicable. And so there's a demonstration that applicants need to make to the department to justify these things. But before I get more into the rules, I wanted to tell you about one of my favorite shorelines, and this is located on the eastern shore of Great Bay area I call Back Bay. So a significant portion of this is located within the boundaries of the National Estuarine Research Reserve at Great Bay. And so you can see here, Great Bay, this is our output from our high resolution tidal wetland maps. You can see that there's a significant amount of mudflat in Great Bay. And so, we're talking this shore here. The other unique thing about this site is this is an area of one of the largest fetches in New Hampshire. So a 3-mile fetch from the northwest, you're having these winds attack. So it's a pretty dynamic place. Notice Google Earth has this cool feature where you can kind of lay down some transects and it will develop a profile. And so, I think there's a lot to learn about natural sites like this. You can see how there's on the previous map, photo, you can see how there's a vegetated ramp. What is the slope of that ramp and what is it comprised of? What's in the middle of it? And how can we use the sites like this as an analog to kind of emulate on other restoration projects? And like Tom said, what is it comprised of? Is it biogenic fully? Is it peat, rocks? And so that recipe is important for when we design new shorelines. Again, just going back to I want to focus on this little frame here. And so you can see, we've got this vegetated ramp. We've got this eroding headland. This headland's been contributing sediment and distributing sediment, sorting sediments. And so probably the fines are going into this tidal wetland. The gravels are staying up here in this beach. And this slope is kind of armoring itself with these boulders and cobbles. And the slope is achieving some sort of a stable slope. If you go in, dig a little deeper, it's pretty amazing what was there in 2016. I can't say what was there now, but mussels and rockweed nestled in, and like Dave said, creating this biogenic landform. But our rules DES rules were largely created with a focus on freshwater conditions. So lake management, rivers, and because our coast is so small, we've generally gotten not very much bandwidth in the rules, but that changed in 2019. But basically I wanted to point out here, you can see that there's this bedrock, this fractured bedrock that's breaking up, contributing gravels to this beach, and all along here are horseshoe crabs. And that's critical spawning habitat for them. Pertaining to our rules, most people know that we have a point system for trees on shorelines, and shorelines, I guess the thing that I like most about this shoreline is every time you go, something is different. It's never the same. Winter, summer, erosion, new species. The thing that's least resistant to change is our trees, are these oak trees which line Great Bay and are actually kind of a bit of a management question for us in that sometimes the decision is to remove these trees, and that is somewhat against a general ethos of environmentalism, but may be necessary if we want to achieve a more herbaceous vegetated landscape, at least at the salt marsh edge. The other species that's resistant to change are humans, and we like to create very linear shoreline landscapes. So in 2016, we completed a shoreline survey. We discovered that 12% of New Hampshire's 326 miles of shoreline have been hardened. But that's not quite the full story. It actually turns out that 70% of the Atlantic coast is hardened, and 93% of the Great Bay shoreline is actually natural. And so the rules that we have established in 2019 is so that future generations can enjoy some sort of natural Great Bay and the services and some functions that provides. So I thought it'd be helpful to talk through the genesis of DES rules, how they came about. DES was created in 1986. There were predecessors to DES, and so rules came, those rules were carried into DES. But in the 1990s, new innovative concepts the need for those were demonstrated, like dam removal and culvert increases and bioengineering on riverbanks. And so DES created certain pathways to incentivize those practices and treat them differently because of their proactive and beneficial nature. And then in 2010-ish, we started mitigation, or in lieu fee program really came on board. So it was that point that we really we have kind of three different types of projects, just straight development, dredge and fill, restoration, and mitigation. And as I've mentioned, in 2019, we've developed a whole new spate of coastal rules. And so now we, as a regulatory agency, have to consider where these projects fit in. Is it restoration? Is it mitigation? Is it straight dredge and fill? Or is it something different? And so I pulled some definitions from the DES rules, and these are for the two references to restoration that I could find: river restoration and wetland restoration. You'll note both indicate setting the trajectory back towards some type of previous condition. But with tidal situations, maybe we can't go back. Maybe the conditions that existed 50 years ago no longer exist, particularly with water level. And as Tom and Dave discussed, our hard marshes exist only at a foot of tidal range. And so if we have already seen a foot of sea level increase, that situation doesn't exist anymore. So maybe it's not the best target to shoot for. So we do have a great mitigation program at DES. It's called the in lieu fee program. So when unavoidable impacts occur on freshwater wetlands, fees are paid into a bank, and those monies are then re-let on a competitive basis to restoration and conservation projects. So Tom put up a slide, or Dave put up a slide earlier today, and I want to just put it up again, that we're in a very unique situation with sea level rise. I just don't think our industry has really grappled with the language that we need to define how we respond to such significant increases of sea level rise. And is restoration the appropriate word? Is mitigation the appropriate word? Or do we need some other mechanism, some other words if we have the right words, we have the right rules, and we have the right mechanisms for payment. So, so there are a couple different trajectories of permitting in New Hampshire, and folks like to know if their project qualifies as a restoration or not. So there's two ways to get restoration permitting. One is you partner with an agency, state or federal, and you get you get certain benefits as minimum impact projects. Specific to living shorelines, if you build a living shoreline that's less than 200 feet, less than an acre, you also qualify as a minimum impact project. So what's the benefit of a minimum impact project? Well, you get expedited review, and I put that in quotes, because the expectation is that when you submit your permit application, all the questions are answered, all the due diligence is performed, and you've already done your consultation. It's really just a paperwork exercise. So expedited is on the time period that it takes for DES to actually process the paper. Other benefits of minimum impact are no square foot impact fees and a flat rate of $400 per permit. But rules exist in this like huge mosaic of federal, state permitting rules, grant rules, and it's just a new, living shorelines is a new concept, and those things aren't all fully aligned. So through my experience with this project, I think we can see where some of the breakdowns in the alignment of the funding and the permitting are happening, and where this project was designed to answer to these new rules and to kind of drill into potential problems with the rules and potential fixes. But I wanted to talk about why it's so difficult to have a straightforward answer about living shoreline projects. So, what is your goal? Is it to restore back to a previous condition, or is it to stabilize some sort of infrastructure? Or is it a combination of both? Maybe it's 90% stabilization, 10% living shoreline. There's also a range of materials that you use. And so how do we evaluate that? Is it based on the volume of materials, hard, soft, green, gray? And then the other thing I've noticed is we're just asked to evaluate really significant levels of sea level rise that have significant levels of variability and uncertainty associated with them. And then, as mentioned, this deals with a lot of trade-offs. And so it's not necessarily an easy question for regulators to answer whether a low marsh is better than a mud flat and it's worth that shift. So now you're ready, you've got a project, you're ready to proceed with some sort of stabilization project. Listed here are the regulatory design criteria. So, provide wildlife, protect against coastal hazards, avoid adverse impacts. I'll just leave this here for reference. And when you're ready to submit a plan or procure an engineer, know that living shoreline projects need to be stamped by an engineer. They need to be stamped by a certified wetland scientist. They need to use native vegetation. And interestingly, if space allows, cutting back on stable banks, flattened slopes of the upland. So some guideposts to consider as you move a project forward. So I'm running out of time, and this slide could take a whole day of workshop. But basically, our new rules incorporate coastal flood risk guidance. And if you are procuring a permit for work in tidal waters, you need to perform a coastal vulnerability assessment. And that involves this stepwise process of evaluating, determining your goals, determining your flood risk, your tolerance for flood risk, sea level rise, groundwater rise, increased precipitation, and then circle back to see if once you've considered all this thing, you're still achieving your goals. And so here's the reference to New Hampshire Coastal Flood Risk Guidance. I wanted to point out too that I think a lot of the folks who've looked at this table, this regulatory scheme now looks at flood risk tolerance as a means to determine which sea level rise to choose. And so I want to just note the red. Just everyone note where the red is. So you see a red curve here, you see probabilities here, and you see these are all related. So the red represents a 1 in 20% 1 in 20 chance of occurring. of sea level rise scenario occurring. So that's a 5% probability. And so if we follow what that 5% probability looks like in 2100, we can follow it over here and see 3.8 feet. So if you have a medium tolerance for flood risk and you're designing for 2100, this is the sea level rise number you pick. We could go into it much further, but for another day. Just wanted to point out some resources that we have available. This newly published planting guide for shoreline erosion management. We also have a web viewer for a living shoreline site suitability model. And we have these awesome new tidal wetland maps that show 22 different classes of attributes that exist on tidal wetlands, including creeks, ditches, pools, pans, and a variety of vegetation assemblages. So just to wrap things up, growing plants is very hard. If you've ever had a potted plant or a raised bed, growing them in salt water is very difficult. And as mentioned earlier, the procurement, installation, maintenance of plants is a primary concern of living shoreline and is expensive. So just keep that in mind. Pre-permitting consultation. The Wetlands Bureau asked me to put this in as the only slide of my entire presentation. So can't understate that. My own personal opinion is that tidal shoreline erosion is a beautiful thing. It's enriching to nearby wetlands, and so consider the no action alternative. This project is kind of demonstrated, I'm a restorator, I've worked in restoration, so we're always looking towards the past, but now with the future, it seems like the future is backing up into us and kind of controlling our decision making, and it's not an easy thing to evaluate. And so, there's a lot of similarities between cake and living shorelines. There's different layers, there's different recipes, they occur at different elevations. And so there's a lot of different varieties. And so there is opportunity here to, when you can, avoid and minimize. And that wraps things for me.